Okay, we're going to be looking at problem number 43 on page 385 from chapter 7. We're going to be looking at, it's a situation where they're giving you the capacity of a ferry both for cars and for buses. So the first part A, just wants to get the mean and standard deviation of a random variable. We've done this process before, so we'll go through pretty quickly. I'm going to start by just clearing out what's there by going to each one, pressing clear and enter on the header of each one. Please don't press delete, because delete makes it disappear, which of course you can reset your calculator and fix it, but that's not ideal. And then we're going to put our original data in our list 1, and I'm going to put the probabilities in list 2. Now, once you have this data correctly in your calculator, the first thing it wants to know is the mean of this random variable. So to get the mean, the formula I'm going to use is it's the product of my scores, which are in L1, and my probabilities, which are in L2. And that's going to give me those products. Then I can do stat, calculate 1 var stats on list 3, second number 3. Oops, try again. And that's going to give me I'm looking at the sum, so that gives me a value of 2.8. So that 2.8 you have there would be the mean of this random variable. Now to go to standard deviation, we go back to stat edit. And since I know it's 2.8, that's my expected value, or my mean. I'm sorry, I'm going to need a parenthesis there. So I'm going to do parentheses of my x scores minus that mean of 2.8. Close my parenthesis and square it. That's going to be my squared deviation multiplied by the probability that occurs. Since not all values are equally likely, I have to use my probabilities once again. Press enter, and I get, that's how much each individual value, 0, 1, 2, 3, 4, 5, contributes to my total variability. So then I can do stat, calculate 1 var stats on L4 this time, and the sum of those values is going to be my variance. So the sum of those values is going to be your variance, and then to get it into the standard deviations, you just are going to need to do the square root of 1.66. So I can go back to the main screen of the calculator and just do the square root of 1.66, and that gives you that information. Now, there is another way you can pull that 1.6 up without having to type in. I can do the square root of, and I can pull that exact value by going to vars, and then down to statistics, option number 5, and then over to sum, and that is going to pull out the most recent value for my sum of my x's. So you can see it really didn't make much of a difference in this case at all, but that is how you could not have to type in the 1.66. For part B, I could work that out in the calculator again, but I'm actually going to show you how to do that by hand. Since it's a much smaller table, it might be just as quick to do it by hand. So for your expected value of y, all I have to do is do my y value of 0 times 0.5, which is of course 0, plus my y value of 1 times 0.3, which is going to be 0.3, plus my y value of 2 times 0.2, so that's going to be 0.4, so that means my expected value is going to be 0.7 buses. Now, to get the standard the variance, I find the deviations, so 0 minus 0.7 is negative 0.3 squared times 0.5, and then 1 minus 0.7, I'm sorry, that should have been a negative 0.7, squared on the first one. And then 1 minus 0.7 is positive 0.3 squared times 0.3. And then for the third one, I should have had 2 minus 0.7 is 1.3 squared, always squaring these deviations to keep the positives and negatives from canceling out, times 0.2. At this point, I'll need to reach for a calculator, and that will give me a variance of 0.61. And to get the standard deviation of y, I just take the square root of that, which is going to be 0.78. Now for part C, it's talking about the amount you are collecting from tolls. And it says that the toll for cars is $3. And it defines this as a, so if the tolls from cars is $3, what I'm going to end up with is that a new variable, I'm just going to do t equals $3 times the number of cars. Now this multiplication is going to affect both the mean and the standard deviation, because multiplication will affect the center of your distribution and the spread of your distribution. So for part C, when I'm going for mean and variance, my mean is just going to be the mean of 3 times cars, which is my x variable actually. So I can replace that C with an x to keep the same variables consistent with the problem. And that is going to give me an answer of 8.4. And then for the standard deviation, that multiplication will affect my standard deviation as well. So I'm going to multiply my 1.2288, also just times 3, and that's going to be 3.864, because multiplication affects both mean and standard deviation. Now for part D, we're going to be basically doing the same thing for buses, except for this time it's charging $10 per bus. So we're looking for the mean of 10y. So I'm just going to take the mean of y and multiply it by 10. So that's going to be $7 from buses. And then same thing for standard deviation. Multiplication is going to affect standard deviation. So the standard deviation of 10y is going to be $7.81 from buses, because you're just multiplying once again. Okay, for part E, we're doing the same thing, but it's for the number of vehicles here. So we're just looking at the total number of vehicles. So the mean value of x plus y, if x is cars and y is buses. When I'm combining those two random variables, I can just add to get the mean of that new random variable x plus y for total number of vehicles. So that's going to be 3.5 total vehicles. Now standard deviation, I cannot add standard deviations, but what I can do is add variances. So basically I have a situation where it's going to be like the Pythagorean theorem, where I'm going to be looking at a variance of 1.28 going in one direction, and then a standard deviation of this going in the other direction. You can graph these if these vectors are independent, and the problem did tell us the number of cars and buses were independent. Then what I can do is I can just be looking for this, which is going to be the that's going to be the standard deviation of x plus y, will be that third side of the triangle. So if they're independent, I know they're orthogonal, or they basically make a right angle. So all I really need to do is use the Pythagorean theorem to get that new standard deviation. Now when I do square things in this Pythagorean theorem, what I'm actually doing is adding variances. So it's important to remember that variances do not add, but standard deviations can. So in this particular problem, we're going to have 0.781 for our buses. I'm going to square that plus the 1.288 for the cars. Squaring that gives you a total of 2.26. And then to get that back in the proper units out of variance and into standard deviation, I can just take the square root of that answer. And so your answer there would be that your standard deviation is 1.506 vehicles. Okay, part F is asking us about this new variable, W, which is the total amount of revenue from both kinds of vehicles, from cars and from buses. So sometimes you'll notice the notation I have here of 3x plus 10y. That basically means I'm going to multiply 3 times x and 10 times y. Now what I would do to solve this is I would first figure out the expected value and standard deviation for 3x and 10y separately. But the good news in this case is using my answer for part C and D, I already have that information. But if I had not already worked that out in part C and D, I would figure out the mean of 3x like I have here, and then the mean of 10y like I have there, and the same thing for standard deviation before I would attempt this problem. Now, looking back at your answer for part C and D, for the mean, all I have to do is add my two mean values, my mean of 3x plus my mean of 10y, and that's a total of 15.4, or $15.40 is my expected value of tolls from vehicles. The other one, I'm going to have to use Pythagorean theorem again because I cannot add variances. I cannot add standard deviations. I have to convert them to variances. So I'm going to have 3.86 squared, and then I'm going to have to add on the 7.81 squared, and that's going to give me that for my variance. And of course, to turn it back into standard deviation, I can just take the square root of my variance, just like I'm using the Pythagorean theorem, and that's going to give me a final answer of $8.71 is my standard deviation. So I would expect to make about 15.40 on average in the long run. That's your long run expected average, but it would be very typical to vary from that amount by about $8.71. So on a typical day, it would be very typical, very usual to have anywhere from about just over $6 to just short of $24 in tolls. And I hope this answers a lot of your questions that you have on this information.